Hello students, today we will start with Unit 2 Class 2, Unit 1 Class 2, which is Open System Interconnection Model, which is a reference model. And we are going to, it is a 7-layer conceptual framework. The implementation framework is TCP/IP framework, so that also we will do a small comparison. Then we will move on to packet switching and circuit switching, and then we will start with data store forwarding. So first we will start with OSI layering concept. So let me start the content. So this OSI is developed by ISO Internet Standard Organization, right? And it is a 7-layer conceptual framework, and it is mainly used for learning, design, and troubleshooting computer networks, right? So these are the major purpose of this OSI model. Right, so the 7 layers, first layer is physical layer, second layer is data link layer, third layer is network layer, fourth is transport, fifth is session, and sixth is presentation, and seventh is application. So whenever you transmit data, it will be in this direction from top to bottom, and whenever you receive data in the receiver side, it will be in this direction from bottom to top, right? So we will start with the first layer, which is directly linked to the physical medium. So this is the physical layer. So it is used to transmit raw bits, transmission of raw bits. So raw bits means it does not have any knowledge about what how the bits are transmitted. Nothing, and the knowledge it is not having any knowledge. It will just transmit zeros and ones, right? So zeros and ones are transmitted in this particular layer. And there are two mediums over here. One is guided medium and another one is unguided medium. And some of the devices that are used in this layer. So the main communication device used here is repeater and hub. Apart from this communication device, the cables as well as connectors. So, for example, in a LAN network, if you want to connect within the system, there will be an Ethernet cable, right? So, that cable consists of connectors which is used to connect to the Ethernet socket. Right, so that type of connectors and all available in this physical layer, and then NIC card, network interface card, is also coming under this physical layer, right? So if you see repeater is a two-port device which is used to transmit signal as well as to boost signal, and hub is a multi-port repeater. Mainly it is of 8 ports, so it is used to connect 8 devices, and it is also not having any knowledge about how to transfer data between different devices which are connected in the hub, right? So what it will do, it will just broadcast to all the nodes that is connected. So there is a possibility of collision domain, which is the disadvantage of hub, right? So next comes data link layer. So data link layer, it uses physical addressing. The physical addressing used by this data link layer is MAC address, which is of 48-bit address, right? So this 48-bit address is divided to two halves. 24 is for vendor ID, and next 24 is to uniquely identify the specific machines, right? So if you see network layer and data link layer, this ERP protocol lies in between this network layer and data link layer. Yeah, as I said earlier, address resolution protocol, this is used to find the MAC address for the given IP address, right? So IP address is given, for that it will find the corresponding MAC address, right? So that is the purpose of this ARP protocol. So ARP can be represented either in the network layer or in the data link layer, because it lies in between network and data link layer, right? As well as it also provides error control. right? Error control, framing, the data which is arrived from the network, the packets which are arriving from the network layer is chunked into number of frames, and each frame is added with the header information which will include source MAC address, destination MAC address, like that it goes off, right? So this data link layer provides a node to node communication, right? So error control consists of error detection as well as error correction. Error correction, the receiver will try to correct it in their side itself. Error detection, the receiver will reject it, and it will ask the sender to retransmit it, right? So error correction and error detection, right? So these are the functionalities of data link layer, and devices used, it can use switches as well as bridges. So switches, in your lab itself, you can see there will be a 24 port switch, right? As well as bridges are used to extend a particular LAN. You can use bridges, right? So switches are used to connect within the LAN, and if you want to extend a LAN beyond its limit, then you can use bridge to extend it. So bridge is also acting with the same MAC address to transfer the data from the source to destination using the MAC address, right? So the protocol data unit here is frame. Here the protocol data unit is in physical layer, it is bits, that is raw bits, right? So node to node communication, how we are representing node to node communication here. So let us consist of source and one switch, switch one, and then router one, and then finally the destination, right? So let me clarify. Finally the destination. So these are the nodes that are available in the internet as of now, right? So source consists of 7 layers. Since switch is acting in the data link layer, it will consist of only 2 layers, and router is available in the network layer, it consists of 3 layers, and the destination is also consist of 7 layers, right? So let's take this particular scenario. So communication from this source to the nearest node, and this node to the next node, and this node to the destination, right? So this is known as node to node communication, which is accomplished by this data link layer. Hence it is represented as node to node communication. Next comes network layer. So here the working principle is host to host communication, right? So as well as routing is the major principle of this network layer using logical addressing. Logical addressing is otherwise known as IP address. Similarly, physical address is otherwise known as MAC address or hardware address, right? So, logical address is otherwise known as IP address. So, this sender is one host, and this receiver is destination is another host, right? So, this host to host communication is known as is established by network layer. Host to host communication using the IP address is established by network layer. And some of the protocols used in this layer is internet protocol, internet control message protocol, and open shortest path first protocol, routing information protocol, right? So these protocols and all we will study when we are moving on to this unit 3, right? So an internet control message protocol, one of the example command already I have told you is the ping command. IP consists of two versions. One is IPv4 and another one is IPv6. So this is of 32 bits and this is of 128 bits, and here the representation is decimal form, and here it is hexadecimal form. right? And the devices used here is routers as well as you can represent gateways. And I have already told you the basic difference. Only two more. It will gateways is also routers with two differences. It will used as entry or exit, as well as protocol conversion is also possible in this gateways, right? And then the protocol data unit is packet here. So packetizing, routing, and logical addressing is the major functionality of network layer, and it provides host to host communication. So next comes transport layer. So transport layer provides end to end delivery. So that means process to process communication, right? So if you see the previous diagram, host to host communication is provided by the network layer. Within this host, there will be a particular application that is executed in this application layer. Similarly, there will be a particular application that is executed in the receiver layer or receiver host or a destination host. Communication between these two processes, right? That is known as end-to-end communication or process-to-process communication, that is established by this transport layer, right? Hence, so the addressing scheme used for this process-to-process communication is port number. Right? For example, already we have seen for HTTP the default port is 80. For HTTPS the default port is 443, right? So that is the port number. So endpoint is nothing but endpoint is a socket, otherwise represented as socket, and it is the combination of IP address plus port number. And this layer also supports error control and flow control. So the difference between flow control and error control: flow control synchronize the speed between the sender and receiver, and flow control either it can do error detection or correction, and it will maintain the reliability of data. So the protocols used in transport layer: a transmission control protocol and user datagram protocol. And then the protocol data unit in this transport layer is segment. So transport layer provides end-to-end delivery, error control, flow control, and it is provide end-to-end delivery is nothing but process-to-process communication. So next comes session layer. So session layer is used to establish, manage, and terminate session. So for this, let me give you a best real-time example. Consider if you are logging to a particular banking website. Let me consider it is a SBI website, right? So once you have given the username and password, and if you left this application idle for 2 or 3 minutes, then after 2 or 3 minutes, if you come back and then click on any of the link in this SBI website, you may identify that it will show the session is closed or the session is invalid, some message similar to this, right? So what this means that automatically the session becomes invalid if you are not working for a certain amount of period, right? So the session is nothing but once an authorized user logs in, until he logs out, whatever the request or whatever the services he required should be serviced throughout the session, right? So the session will be established first, maintained, and then terminated. So these are some of the conditions where the session will close automatically, because SBI similar to banking and all consisting of transactions which is very confidential, as well as it is as well as it should not be violated, right? So if you are trying to click on any other link which you are not authorized, automatically your session will be closed. For example, double clicking a link, that will also lead to closing of your session, right? So these are some of the real time examples where session comes into picture, right? So it can be also represented as dialog control, right? And the protocol used here is NetBIOS session RPC, right? So the key role of this session is session control and recovery, right? So that is what represented in this session layer. It is very much mandatory. It is for dialog control. Maintaining the communication between the client and server will be done by this session layer. So RPC is remote procedure call. So next comes presentation layer, right? So if the sender wants to communicate with the receiver, what format, for example, if it is a Word file, same Word file format should be communicated in the receiver side also, right? So the format should not be changed, right? Similarly, you can also represent, if you are representing an image file as JPEG, same JPEG file formatting should be used here to process that particular image, right? So that is what the format data formatting is done by this presentation layer, as well as it will also do encryption, decryption, and finally compression, which is used to efficiently utilize the bandwidth when it is transmitted, right? So example here, JPEG as well as ASCII, American Standard Code for Information Interchange, right? So it is used to represent the text as well as the symbols, whatever we are typing from the keyboards. And JPEG is it is a format to represent an image, like that audio file, video file, MPEG is also there, right? So that type of formatting will be done by this presentation layer. So encryption decryption is providing security, right? So secure socket layer, transport layer security comes into picture to provide security for the session what we have established, right? So the duty of this presentation layer is to make data readable for applications. So next comes application layer. So the application layer, it is directly user can access only this particular layer. Remaining layer and all not reachable directly from the user, because application layer is a user interface which is directly available to the user. So it provides network services directly to user application. Examples are HTTP, FTP, SMTP and DNS. So HTTP protocol, hypertext transfer protocol, which is used in web browsers. FTP for transferring large files, we are using FTP protocol, file transfer protocol, and DNS, domain name system, which is already I have taken what is DNS. It is to map between the IP address and domain names. And SMTP, simple mail transfer protocol, for it is like a client server process, storing and retrieving emails from the server and serving it to the users, right? So the user interaction for this layer is yes. Remaining layers user interaction is no, because it is directly communicated to the upper and lower layers, but this application can be able to communicated with the user, can be, right? So with this we are completing OSI model. Next we will move on to a small comparison between OSI model and TCP/IP model. So if you see here, the first two layers, data link layer and physical layer, is converted to link or network interface. Otherwise, it is represented as host to network layer. Right? And the network layer is represented here as internet layer. Transport layer is represented as it is as transport layer. And these three layers, session, presentation, application, is merged into a single application layer in the TCP/IP model. right? So here we are representing frames as well as bits in this protocol data unit, packets, segments, and data, right? So remaining concepts of explaining, so application layer consists of presentation and session. So data formatting as well as dialog control will be included along with the application layer, right? So next we will move on to packet switching and circuit switching. So as I said earlier, just OSI is a theoretical and it is used for educational purpose. TCP/IP is a real world networks, right? So next, packet switching versus circuit switching. So first we will start with circuit switching. In the circuit switching, a dedicated path is established between the source and destination. For example, consider terminal 1 wants to communicate with terminal 6. There will be a dedicated path. So switch 1 to switch 3, switch 3 to switch 4, switch 4 to switch 5, and then it is reaching terminal 6. So there is a dedicated path between the source to destination, which is known as circuit switching, and the entire bandwidth will be utilized by the source and destination. So if you come for packet switching, let us consider there are 5 packets that are available in the sender, 1, 2, 3, 4 and 5, right? So each set of packets will take different path to reach the destination. Let us consider 1 and 2 is traversing in this direction, 3, 4 and 5 is traversing in this direction. And then now 4 is taking this path, but 3 and 5 is taking this path. So like that, so and 1 and 2 is traversing like this, right? So a different packet is taking different path to reach the destination, right? That is known as packet switching. There is no constant path between the source and destination, and this method uses store and forward switch to uh, store the data and then forward it, right? So since it is since the packets are traversed in different path, here it will receive at out of order, right? So receiver has to order it in sequence to maintain the sequential of the packets 1, 2, 3, 4 and 5, right? So packet switching, what is packet switching? So let's see the theoretical information about packet switching. Packet switching divides data into small packets, send them independently and reassemble them at the destination. Key characteristics: no dedicated path, packets may take different route. It is efficient to use of bandwidth because whenever there we are not forcing it to take the same uh, path, so it will use the bandwidth efficiently. Some packet may be delayed or lost. This is the disadvantage of it. So example, internet communication, email, web browsing, video streaming, and protocol used here is IP and UDP, and it is working in the network layer of OSI model. So next comes circuit switching. So what is circuit switching? It establishes a dedicated communication path between sender and receiver before data transfer becomes, right. So similar to telephone network, right? So once you have given all the numbers, dialed up all the numbers, automatically a dedicated path is like between the sender and receiver. Until you cut the connection, the path exists, right? So the key characteristics: dedicated path for entire session, fixed bandwidth, very low latency once connected, inefficient if the line is idle because the entire bandwidth is wasted. So the example is traditional telephone network, and ISDN networks is also available, right? So this earlier ISDN networks are used for data communication, so that is also represented here, and it is working in layer 1 and layer 2, right? So we will see a small comparison between packet switching versus circuit switching. Feature: packet switching, circuit switching. Connection setup not required for packet switching. Whenever there is a packet, you can just forward it. But in circuit switching, connection establishment is required before transferring packets. And path, this is dynamic, it will choose any path to reach the destination, but in circuit switching it is fixed. And bandwidth usage, it is efficient, and circuit switching it is inefficient. And the feature here is delay, and then packet switching is variable and circuit switching is constant. So failure handling feature, packets are rerouted, that means if the packet is lost it will retransmitted, and circuit switching, it will drop the call. And example, internet, and this is telephone calls, right? So store and forward method we will discuss in the next class. With this we will conclude today's session. Thank you.